question that you guys wanted us to worry about. And this one is based on analytical geometry, right? Absolutely awesome. And it comes from Tumi Tumega. Let's go right into it and see what the story is here. It might not be nicely visible for you, so I'm going to read some of the work that is appearing here, or the love letter, so that you guys can be able to see or understand what we are going to do. So thank you, Tumi. Let's get on with this question. The question reads as follows. It says the circle with the center 2:-3 passes through the point A with coordinates 6 and -1, and through point B as well. So point B is that point there. Point A is this point there, right, which lies on the y-axis. P with coordinates 4 and K is a point such that PA is a tangent to the circle. And there's a diameter ACD that is supposed to be drawn, which we don't see. We will construct the diameter once we get to a question that talks about the diameter. So this here is a tangent, and we can all see that indeed it is a tangent that you're being given, and I'm certain that you're going to be asked very exciting questions about this tangent. So the first question says, determine the equation of the circle in the form x minus a squared plus y minus b squared is equal to r squared. Equations of a circle, beautiful stuff, no complications. You guys should know how to handle those kinds of questions. So if I may just show you what we're dealing with. We've got a nice circle, of course, and so far we are being told the coordinates of the center. We know that the center of this is point C, and the coordinates of C were given to us as 2 and -3, right? And there's a point somewhere there with coordinates 6 and -1, which is point A. We want to find the equation of this circle, right? The equation of a circle that is centered anywhere in the world will always be given by x minus a squared plus y minus b squared is equal to r squared, right? Now, what is this a and this b? Well, this a and this b is basically where the coordinates of the center are going to be positioned. That a and b is for the center. So my a is 2 and my b is -3, right? So let's sub them. X minus 2 squared plus y minus minus, it's going to be plus 3 squared is equal to r squared. All right, but now what is this r? Well, this r here that you guys are looking at is simply the radius of the circle. Now I'm looking for the radius of the circle. For me to work out the radius of the circle, I just need to know how long is this AC. That is certainly going to be our r, right? There are two ways of working the value of that particular r. I can use the distance formula and work out the length of AC. Alternatively, I'm going to be smart about it by just taking the coordinates of A and sub them as x and y in the equation of the circle, because this circle does pass through point A. So where I see x, I'm simply going to put 6, right? And where I see y, I'm putting -1 plus 3 squared is equal to r squared. Once I'm done with this, then it's just a matter of cleaning up. It means my r squared is going to be 2 squared, that's 4. This is 4 squared, which is 16. The sum of which will amount to 20. Therefore, the equation of the circle will be x minus 2 squared plus y plus 3 squared is equal to 20. Awesome question. Right. Let's move on to the second part of the question. The second part says to us, we need to now determine the equation of the tangent. So now they want you to find the equation of the line AP. That's the equation we are interested in. We want to know what's the equation of that line. More often than not, we all know that if we want to find the equation of a straight line, we need two things. The ingredients that you need are always the gradient of the line, and you also need to know a point that the line passes through. Fortunately, we've got point A with coordinate 6 and -1. We are covered on that department. The problem is the gradient of the tangent, right? Now, it is at this point where you're going to now engage your knowledge of Euclidean geometry to try and figure out the gradient, because what do we know about tangents? We know that the tangent and the radius are perpendicular to each other. So if we can find the gradient of the radius, we can use it to find the gradient of the tangent, because since they are perpendicular from our knowledge of Euclidean geometry, we know the gradient, the product of the gradients of two perpendicular lines will always give you an answer of -1. So I'm going to find the gradient of the radius. Once I know it, I'll use it to find the gradient of the tangent, and then I can be able to find the equation of our tangent. Great stuff, right? So let's come back and check what will happen here. Okay, so I'll begin first of all by trying to figure out the gradient of the radius, right? That's our equation. We're looking for the equation of the tangent, right? This is basically what we're interested in. Okay, cool. So what do we know so far? Well, if I may just use the diagram I just drew for you guys. There's a tangent, and this tangent is a line. I'm going to draw it in white. It passes through point A, of course. It is tangential to the second at point A. It has a point P as well with some weird coordinates of a number and another variable. So I'll start first of all by working the gradient of AC, right? We'll work out the gradient of AC. Okay, that's the gradient of the radius. So the gradient of the radius AC will be changing y over changing x. y2 minus y1 over x2 minus x1. So changing y over changing x. Okay, that's basically going to be, if you check my y's, I'll just simply have negative y minus minus 3 and then 6 minus 2. That's what I'm going to be sitting with here, right? So negative 1 minus minus 3 will become plus 3 over 6 minus 2. These are the points of A and C. On the numerator, you've got 2. On the denominator, you've got 4. So the gradient of the radius comes out as exactly 1 over 2. Now, if this is the gradient of the radius, then it means that we can conclude that the gradient of the tangent will just become negative 2. Why? Because, this is the mathematical symbol for because the gradient of the tangent multiplied by the gradient of the radius must give us negative 1, since the radius is perpendicular to the tangent. This is our knowledge from Euclidean geometry. You need to always indicate your reasons for these kinds of arguments. So if one comes out as 1 over 2, the other one will have to be negative 2, so that when you multiply them, you end up with a product of negative 1, because those two lines are basically perpendicular to each other. Now that we've got our gradient and our point, we know now that the gradient of the tangent is negative 2, and my tangent passes through a point with coordinates 6 and negative 1. I'm then going to engage my y is mx plus c, right? For y, we're going to have minus 1. M, we have minus 2. X, we're going to have 6 plus c. Then this is minus 1 is, or negative 1 equals to negative 12 plus c. So 11 is c. Therefore, the equation of the tangent, right? The equation of the tangent is just given by y is negative 2x plus 11. Beautiful stuff, right? Okay, cool. Now let's go on and see what the next question is going to be. As long as you understand your story when it comes to the foundation or the basics of gradients and tangents, you will know that they're perpendicular to each other. So if you know one gradient, you can use it to find the other gradient. The third question says, now we need to find the value of k. Hence, find the value of k. Okay, where is this k? Well, k is a point, it's a coordinate on the point P. The coordinate of the point P were given to us as 4, and the y coordinate appears as k. Now, if I know the equation of that line AP, which happens to be the tangent that they were asking us to find in the previous question, I can just simply replace both x and y in the equation of the tangent to try and figure out what the value of k is going to be. This is very straightforward. No complications. One x coordinate is going to be 4. The other coordinate, which is the y coordinate, is going to be k. So we've got 4 and k as the coordinates of P. Right. So for that next question, which is happening to be the third question, right, for number 3, we know that point P has coordinates 4 and k. And this point is a point on that straight line, which happens to be the tangent we just found the equation to. So I'm going to say y is negative 2x plus 11. So my y value will be k. Negative comes back, 2 comes back. The x value is 4. And this must be added to 11. We then end up with a k value of exactly 11 minus 8. The answer becomes exactly 3. So that's going to be the value of 3, which means now that the coordinates of P, which is what they did not ask you, but I'm just putting it here so that you can see what is going on. There will be actually 4 as well as 3. Those will be the coordinates of K. Of P. They just wanted the value of K, so we got that the answer for that is going to be K is equal to 3. Right. Number 4. Okay, so number 4 says, now hence prove analytically, right? So let's go to it. We're going to have to prove analytically. They say to us here in question number 1.1.4, hence prove analytically that PB is a tangent to the circle. Okay, cool. So let's go back and check the diagram. We've got point P, all right? There's point P there. We're happy with point P. So we are saying, if you could succeed to draw a straight line to B from P, that line will also happen to be a tangent. So they're saying that this is also going to be a tangent in this particular question, right? So we need to use analytical methods to prove that indeed PB is going to be a tangent. Okay. Now allow me to clear a lot of things here so that we are working on something that we are looking at right now. So I'll just remove the stuff we've written so far so that you guys can see what is happening. What do we know so far? Well, we know that point P, right, has coordinates 4 as well as K, and our K came out as 3. We are now interested in finding the coordinates of B, because if I must use analytical methods, I need to use analytical geometry. You can apply your Euclidean geometry techniques, but then that will actually cause a problem. We don't want you to do that. We want you to use analytical methods. So what I'm going to attempt to do, I'm going to attempt to show that this line and the line BC are perpendicular to each other. BC is the radius of the circle. If I can show that those two lines are perpendicular, then it would mean that the line BP is a tangent to this particular circle, because only tangents are perpendicular to radii in a circle, right? But I can't find the gradient if I don't know what the coordinates of B are. But what do we know so far? Well, we've got something that we know about point B, and that's the fact that point B lies on the y-axis. That means its x-coordinate will definitely be 0. So we are only missing the y-coordinate. Now someone is asking, where are we going to get the y-coordinate? Well, don't worry. What do we know? We already know the equation of the circle from previous work. We did find that x minus 2 squared plus y plus 3 squared equals 20 is the equation of the circle. Now, if I'm just going to substitute the 0 where I see x and try to figure out what the y value is, I'll be able to find the coordinates of B. So which means you're going to have 0 less 2 squared added with y plus 3 squared must give us a value of 20. That's 4 from 2 squared. So you're simply sitting with y plus 3 squared equals to 20 minus 2 squared, which is going to give us 16. I just moved 2 squared, which is 4, to the right hand side. It became 20 minus 4. We end up with 16. To remove that particular square, we're going to have to take the square root on both sides. Remember, it must be plus minus when you take a square root of any number. So you sitting here with y plus 3 equals plus minus 4, which means y is equals to negative 3 plus minus 4. So one y value has to be negative 3 plus 4, which is 1, or the other y value is going to be negative 3 minus 4, which is going to be minus 7. What does this suggest? It suggests that x is 0 on this circle at 2 places, when y is 1 and y is minus 7. Clearly, you can see that the negative 7 value will definitely be the one at the bottom below the origin. Below the origin, that's where negative 7 is going to be. That means the coordinate of B will be 0 and 1. Now I can proceed and work out the gradient of the line BC. So the gradient of BC will be changing y over changing x. So it's going to be minus 3 minus 1 over 2 minus 0, which is going to give us an answer of exactly negative 4 over 2, which is going to give you negative 2. Right. After that, we then look for the gradient of the other one, BP, which is also going to be changing y over changing x. So that's going to be 3 minus 1. It's going to be 3 minus 1 over 4 minus 0, which gives you an answer of 2 over 4, which is exactly 1 over 2. Now, you will notice that the gradient of BC multiplied by the gradient of BP is negative 2 times a half, which gives us an answer of negative 1 over 2. That then, folks, means that we can conclude that BP is a tangent because BC is a radius and only a tangent would be perpendicular to a radius. So my conclusion will be, therefore, BP is perpendicular to BC, which makes it a tangent. Therefore, BP is a tangent because it is perpendicular to the radius. Therefore, this is going to be a tangent since it's perpendicular to our radius. I hope this has helped you to see what is going on if anybody ever asks you to figure out whether something is a tangent or not using analytical methods. You have to use analytical geometry. No other concept of math is being requested in this particular question, so you had to definitely use analytical geometry. Right, so let's move on to the other exciting parts of this question. It is basically 1.2. If you look at 1.2, it's an awesome question. We are being told that there's a circle, right? It says a circle is represented by the equation x squared minus 2x plus y squared plus 4y minus 4 equal to 0. First question is asking us to find the coordinates of the center M and the radius of the circle. Right, let's go and see. Coordinates of the center M and the radius. So we are now on question 1.2, right? We are on question 1.2. 1.2, that's where we are. We're being given the equation x squared minus 2x plus y squared plus 4y minus 4 is equal to 0. Then we're being asked to find the coordinate of the center of this circle. Remember, guys, you can't find the coordinate of the center if you don't rewrite the equation in the form x minus something squared plus y minus something else squared equals r squared. If you can succeed to do this, then you'll be able to see what the coordinates of the center are going to be, because it will definitely be this number here, A, and that number there, B. Be careful of that. So in this case, since we are looking for this form, the center format, we need to change this from the expanded format to the standard form of the equation of a circle by completing the square. Okay, so how do you do that? Well, first of all, I've got x's here. I always say to my learners, keep the x's together and keep the y's together, and then the constant obviously can go to the right hand side. So I'm going to basically say the following. I've got x squared, I'm going to rewrite that. There's x squared. There's minus 2x, there's minus 2x. So for the x's, we're going to add, we add the third term. What's that? This third term we're adding is always half of this negative 2 that you're looking at here. It's always half of this number that you see here. So half of negative 2 is simply negative 1 squared, right? Always put a square on it if you are completing the square. Then you've got y squared plus 4y, and then for the y's, I'm adding once more half of 4. I'm going to add half of 4, half of 4. Half of 4, beautiful people, is simply 2, so I'm just simply adding 2 squared. But what you do on the left, you obviously need to repeat the same thing on the right hand side. When you're completing a square, everything new that you're writing needs to have a square. So I just added half of negative 2 on both sides of the equation, and I added half of 4 on both sides of the equation, and I also remember to always put a square. Right, I always tell my learners as well, if you are here to complete the square, you just take a term from the square, and you take a term from the square, you make a square. Right. On the y's, y squared plus 4y plus 2, take the term from a square and take a term from the square and make a square. And then on the right hand side, we've got 4 plus 2 squared is also 4 plus 1, that's 4 plus 4, 8 plus 1, which gives us a value of 9, which means this circle is basically a circle with the center, the examiner said the center is M, with the coordinates 1 and negative 2. They didn't ask for the radius, just be generous to them and tell them that if you people also want the radius of the circle will not be 9, but it's going to be 3, because what you are looking at all the time is not the radius. This number you're looking at is always r squared. So if r squared is 9, you take the square root on both sides. Your r is going to be 3. Remember, the radius will always be a positive value. It will never be negative. So that's the center, 1 and negative 2. The last question says something very exciting to us. It says to us here, give the equation of the tangent parallel to the x-axis. Oh, that's a serious question. Very, very serious. Give the equation of the tangent that is parallel to the x-axis. The tangent of the circle parallel to the x-axis. Let's try to make sense of that. Okay, cool. So the second part, this is 1.2.2, obviously. We've got a circle, right? Let's have that circle so that we can all see what the examiner is interested in. Here is the circle, right? What do we know so far about the circle? We know the center of the circle, the coordinates of the center. We've been told that M is going to be the center. So we just found that the center is going to be 1 and negative 2. Which quadrant will that point lie in? That point is certainly going to lie in the 4th quadrant, which means the x-axis has to be somewhere here and the y-axis has to be somewhere there. If I had to draw a complete Cartesian plane, it will certainly look like what we're sitting with now, where x is positive and y is negative. Now we are interested in finding the equation of a tangent. A tangent is a straight line that cuts the circle or that touches the circle at one point. So these tangents that you're interested in, right, are simply going to be lines that are parallel to the x-axis, which means one of them is this one, passing at the top, parallel to the x-axis. The other one has to be here at the bottom. Definitely has to be here because both those two are tangents that are parallel to this thing that I'm currently looking at right now. Okay, that tangent is not coming out quite nicely. Let me draw it freehand. It's going to come out very terrible, but then let's just try and see. So this is the second tangent, tangent number 1, right? And tangent number 2 at the top. We are looking for the equations of those tangents. These tangents must be parallel to the x-axis. The examiner said they want them to be parallel to the x-axis, and we know for a fact that the white line happens to be the x-axis. Now, this is pretty straightforward, no complications, guys. For you to know what the equation is going to be, this will definitely be given by y equals to some number. So you want to know what is the value here of y, where this tangent is going to pass. So this is a game of just figuring out how many moves am I making if I'm moving up. Because if you're going to move straight up to the tangent, you're going to move in a fashion that is going to make sure that that line becomes parallel to the y-axis and perpendicular to your tangent. So how many moves are we making from point C to the point of contact? You're obviously making r moves. That's the radius of the circle. And according to what we worked out, we know that the radius of the circle is just simply equal to 3. So when I'm moving from negative 2, I'm going up 3 units. I'm certainly going to end up at 1. That means the equation of the first tangent will just be y is equal to 1. Great stuff. And then for the second one, the second tangent, let's just see the second tangent and what's going to happen with the second tangent. The second one, I'm not going up now, I'm now going down. So I'm moving down a certain number of units. Again, I'm coming to this point of contact. So I'm asking myself, if I'm at negative 2 and I'm moving down, which means I'm moving down how many units? Radius units. So I'm moving down 3 units. I'm using the number 3, guys, because 3 is the radius of the circle. You're moving from the center, going straight to the tangent. You're definitely going to move 3 units. And then you'll notice that we're certainly going to end up with a value of negative 5. That means the equation of the second tangent will just be y is equals to negative 5. So this is how you would find the equations of the lines that happen to be tangents to this circle at the point of contact.